Step 1 of this process is to obtain a water analysis. This is done by a water treatment professional. If analysis was already completed, it cannot be more than 5 years old. You must measure at minimum the concentration parameters in the credit requirements, highlight each parameter, and then identify the source of the makeup water and the process for analysis. The maximum concentrations for the parameters in the condenser water can be found on Table 1. These are later used in Step 2. In Step 2, you calculate the cycles of concentration, and basically you determine how many times the cooling water or evaporative condenser water can circulate throughout the system without creating performance or operational issues. And this is done by using equation 1, which compares the acceptable maximum concentrations in condenser water and the parameter concentrations in the makeup water. So here's an example for this calculation, and you see the makeup water concentrations in Table 3. Those are done by the water analysis. And then in Table 4, you calculate the cycle of concentrations by taking those makeup water concentrations and those maximum allowable concentrations and comparing them. In Step 3, you identify your limiting factor, and this is done by finding which parameter has the fewest calculated cycles before it reaches the maximum concentration. And in this case, you see that the maximum would be 5 cycles. Step 4, you set your cooling tower or evaporative condenser cycles by adjusting the cooling tower for the maximum number of cycles without exceeding concentration levels or affecting the operations. Step 5, you increase your system performance by either increasing the number of cycles by treating the water or supplementing your makeup water from a non-potable source. And you must evaluate whether greater potable water efficiency could be achieved by treating the makeup water, and the non-potable water derived from the site can offset a portion of the potable water used for the makeup. These are some non-potable sources. They consist of condensates from air conditioners, steam systems, ice machines, and then food steamer discharge water, fire pump test water, and rainwater. Advantages and disadvantages, we're looking at you get a reduction in your water usage and costs, reduction in chemical uses, reduction of suspended solids, and your decrease in maintenance costs. However, the dissolved solids increase as cycles of concentration increase, and this can cause scale and corrosion problems. So the suspended solids kind of is on both sides. You decrease the remaining solids by decreasing how much makeup water is added, but on the other end of the spectrum, the increase in cycles is essentially looping the remaining solids in the system, and those specific solids can build up on the components and cause scaling and corrosion. These are the required documents to achieve the points. For 1 point, you need the potable water analysis results, potable water analysis narrative, and the cycles of concentration calculations. For 2 points, you need those 3, as well as non-potable water calculations, water treatment calculations, and non-potable water analysis, if you're using 100% non-potable water. We found a project that NASA had that they used this credit, and so they actually doubled their cycles, their maximum cycles. They reduced their water usage by over 800,000 gallons. They reduced their water and sewer bill by over $5,000. They eliminated chemical treatments, and they reduced their electrical bill by about $27,000. Some related credit tips for the WE prerequisite indoor water use reduction. The related prereq requires makeup meters, conductivity controllers, and overflow alarms, and efficient drift limit eliminators that reduce drift to a maximum of 0.002 of